My dear students, good morning all of you. Earlier we discussed about the force and field in electrostatics regarding point charges. Now we are going to calculate the electric field intensity or force for continuous charge distribution. So first of all, we must know what is meant by this continuous charge distribution. If a system consists of a large number of charges along its length, area or volume, then it is said to be continuous charge distribution. That is, this charge distribution is of three types: linear charge distribution, surface charge distribution, and volume charge distribution. So, first of all, we must know continuous charge distribution. What is meant by this continuous charge distribution? That is a system which consists of a large number of charges along the length, area or volume, then it is called continuous charge distribution. For example, if you consider when a glass rod is rubbed with a silk, then you will get opposite charges on the silk cloth as well as on the glass rod. There you can find large number of charges, which is considered to be a continuous charge distribution. But here these types of continuous charge distribution, first one is linear charge distribution. That is continuous charge distribution. The first one, linear charge distribution, means if the charge is distributed along the line or along a curve or along an arc of a wire, then it is considered to be linear charge distribution. Then the corresponding linear charge density is nothing but the charge per unit length. That is, if the charge distribution is along the length, then it is called linear charge distribution. Once you got the idea of this, then what is linear charge density? That is, in the case of this, linear charge density means it is denoted by lambda. It is charge Q by length L correspondingly. That is Coulomb per meter. coulomb per centimeter. You can take like that. So this is, if the charge is distribution is along the length, then it is called linear charge distribution. If you are going to find out the charge on any particular elemental quantity, we have to use linear charge density formula. It is charge by length. The charge per unit length is simply called as linear charge density. Next one, second one is surface charge density. That is, if the charge is distributed over its area, then it is called surface charge density. If that is the case, this is surface charge distribution, sorry. It is the surface charge distribution. Then it is called as, if the charge is distributed over its area, then it is called surface charge distribution. And once you got it, then we have the surface charge density. Surface charge density denoted by sigma. It is simply nothing but charge Q by surface area. Capital A. This is coulomb per meter square. And the third one is volume charge distribution. That is, if the charge is distributed over its volume, then it is called volume charge distribution. So, volume charge distribution means if the charge is distributed over its volume, then it is called volume charge distribution. Therefore, volume charge density. Correspondingly, it is denoted by rho. Then it is given by charge Q by volume V. Charge Q by volume V. This is the coulomb per meter cube. So, there are three types of charge. Suppose if you have a three-dimensional object and if the charge is distributed over its volume, then we have to consider volume charge distribution. If the charge is distributed over its surface, that is a plane object like a thin disk. If the charge is over its surface, then we have to consider the surface charge density like that. If that is the case, so these are the three types of charge distribution. Basing on that, you may be asked to calculate the, you may be asked a question like this. A circular ring of radius R, of radius capital R, is carrying a charge Q. Is carrying a charge Q. is carrying a charge q on its surface. A circular ring of radius capital R is carrying a charge q on its surface. Find, or otherwise a circular ring of radius capital R having a uniform charge distribution q on its circumference. Having uniform, a circular ring of radius capital R having uniform charge distribution along its circumference. Let Q be the charge on its surface. Then find the electric field intensity. Then find the electric field intensity on the axis of the ring at a distance x from its center. This is what you are given, a circular ring. See that? A circular ring of radius capital R having uniform charge distribution along its circumference. Let Q be the charge on its surface. Then find the electric field intensity on the axis of the ring at a distance x from its center. And at what distance? Suppose you may be given another question also here. We wait, there you can write at what distance the electric field intensity is maximum, and find maximum value of E. There you may be given this type of a circular ring of radius R having a uniform charge distribution you are given. At what distance the electric field intensity is a maximum, and find the maximum value of electric field intensity. It's very simple. For example, if you are given, this is the circular ring of radius capital R. Then what you are given is, let us say all the charge resides only on its surface along its circumference. Okay. Now you are asked to find out if this is the ring. The line that is passing through the center of the ring and perpendicular to its plane is nothing but the axis. So let us consider this is the point P. At that point you have to consider the electric field intensity. This is the radius R. Now you are considering this at a distance x. Whenever you are going to find out the electric field intensity due to any charged body, first we have to consider an elemental quantity And for that elemental point, you have to find out the electric field intensity at a given point. Thereafter, it should be integrated in between the required limits to obtain the field at the point due to the entire object. So, first we have to consider an elemental length dl at this point. Now, you have to find out the field at P due to elemental length, this one. Suppose if this is making an angle theta, then this we can resolve it into two components like this. If this is theta, this becomes dE cos theta and this becomes dE sin theta. If this is R and this is X, then it is root of R square plus X square. And once you got the idea of this, then what we can write in this case is here. First of all, the quantity of the elemental length is given, then charge on elemental length is given by, it is nothing but dq, which is nothing but elemental length into linear charge density. Linear charge density. Therefore, this what you can write is here, dq is equals to elemental length is how much? dl into linear charge density, total charge q by total length is 2 pi r. This is the formula to find out the electric field length. Therefore, this electric field intensity at P due to elemental length. If you want to calculate first, then dE is equals to 1 by 4 pi epsilon naught into dq by r square plus x square. Because according to Coulomb's law, 1 by 4 q by r square. But r square means root over r square plus s square whole square means that one. But this can be written as 1 by 4 pi epsilon naught into q by 2 pi r into dl by r square plus x square. Now, this field can be resolved into two components as dx is equal to dE cos theta along x-axis and dy is equal to dE sin theta along y-axis. And therefore, here the point is due to symmetry. Due to symmetry, here what you can take? Due to symmetry, d sin theta components cancel each other. Hence, the field is due to the component dE cos theta 1 due to the component dE cos theta only. Therefore, Once you got the idea of this, then now what you are going to get, dx is equals to d cos theta. That can be written as d means 1 by 4 pi epsilon naught q by 2 pi r. This is capital R only, all the time you have taken. And here q by 2 pi r into dl by r square plus x square into cos theta, adjacent side, x by root of r square plus x square. Therefore, here electric field intensity at P due to the ring, the charged ring, is given by Ax is equals to how much it is, integral d cos theta from 0 to 2 pi. Because along the length only, so here only dl is variable. So other quantities can be taken out as common. Therefore 1 by 4 pi epsilon naught into q by 2 pi r into x by r square plus x square whole power 3 by 2. This whole thing is taken out as common, and then integral 0 to 2 pi r into dl. Therefore, that Ex is given by 1 by 4 pi epsilon naught q by 2 pi r into x by r square plus x square whole power 3 by 2 into 2 pi. Because integral dl is L and inverse the limit 0 to 2 pi r. Therefore 2 pi r. This 2 pi r cancel. Therefore, the electric field intensity Ex is equal, E is equals to root over Ex square plus Ey square. That can be written as root over Ex square plus 0. Therefore, E is equals to Ex. That is nothing but 1 by 4 pi epsilon naught into Qx by r square plus x square whole power 3 by 2. This is the standard formula for the electric field intensity due to a charged ring. And now here there are points. Case 1 at x is equals to 0, that is at the center of the charged ring. E at the center should be 0. Since x is 0, this must also be 0. Now at what distance that E value is maximum? This is the formula. 1 by 4 pi epsilon qx by r square plus x square whole power 3 by 2 is the formula for the electric field intensity. That b bit also are given. Now if d by dx is equals to 0, then the electric field intensity is or then E is simply called as maximum. Therefore, d by dx of 1 by 4 pi epsilon naught qx by r square plus x square whole power 3 by 2 should be taken as 0. Or d by dx of x into r square plus x square whole power minus 3 by 2 should, because q by 4 pi epsilon is constant, that is taken out, taking that side becomes 0. And once you got it, this is the product of two variables. Then it is first function, derivative of first function into r square plus x square whole power minus 3 by 2 plus x into derivative of second minus 3 by 2 into r square plus x square whole power minus 3 by 2 minus 1 into derivative of x square is 2x. This must be equal to 0. This and this gets cancelled. Therefore, r square plus x square whole power minus 3 by 2 is minus 3x square into r square plus x square. This goes that side, it becomes plus minus 3 by 2 into r square plus x square whole power minus 1. This term and this term gets cancelled. Therefore, 3x square by r square plus x square. Therefore, it is given by r square plus x square. 3x square is equal to r square plus x square. So 2x square is equal to r square. X square is equals to r square by 2. Therefore, x is plus or minus r by root 2. So, it is maximum and x is equal to r by root 2. Once you got it, then E max is given by 1 by 4 pi epsilon naught q into r by root 2 by qx by r square plus x square r square by 2 whole power 3 by 2. That what you can get it is 1 by 4 pi epsilon naught q into r by root 2 into 2 power 3 by 2. This is 3r square 2 root 2 by 3r square whole power 3 by 2. That is 1 by 4 pi epsilon naught q into r by, this is how much it is? 3 cube, 27, 3 root 3 r cube into 2. Therefore, this 2 times cancel, this r square cancelled, therefore it is q by 6 root 3 pi epsilon naught r square. This is the maximum value of electric field intensity in the first case. Here this is a model where the charge is distributed along its length or circumference. So that while calculating the electric field intensity, we used the linear charge density. Suppose if you are going to calculate field, the second one is, you may be given that a disk of radius capital R has a uniform charge distribution on its surface, having surface charge density sigma. A disk of radius capital R has a uniform charge density on its surface, having surface charge density sigma. Find the electric field intensity on the axis of the disk at a distance x from its center. At a distance x from its center, that we are going to calculate. So, a disk of radius capital has a uniform charge distribution on its surface having surface charge density sigma. Find the electric field intensity on the axis of the disk at a distance x from its center. Then here, whenever the charge is distributed over its area, we have to consider the surface charge density. Then here, for to arrive this one, it is simple. This is a disk of radius capital R. Now we are asked to calculate. This is also, if this is the disk, we have to find out this point P must be perpendicular plane, which you can draw. Let us say this is at the point P. Now this is at a distance x. Now a disk is considered to be a several number of concentric circular rings. Let us consider a circular ring. Consider a circular ring of radius r and thickness dr. Let us say this is radius capital R. Now you are going to calculate the electric field intensity at this point P. If this is x, then this is root over r square plus x square. Now once you got this, already we calculated. So consider an elemental ring of radius small r and thickness dr. Then, therefore, charge on elemental ring. The charge on elemental ring dq is given by area into surface charge density. Area is nothing but length into thickness, that is 2 pi r into dr into surface charge density sigma. Therefore, once you got the idea of this, now the electric field intensity at P due to elemental ring, it is given by dA is equals to 1 by 4 pi epsilon naught dq into x by r square plus x square whole power 3 by 2. Because already we know the formula for that. Therefore, dA is equals to 1 by 4 pi epsilon naught 2 pi r dr into sigma into x by r square plus x square whole power 3 by 2. Then this 2 pi cancelled this one. Therefore, d is given by sigma by 2 epsilon naught, sigma x by 2 epsilon naught into r dr by r square plus x square whole power 3 by 2. This is the one. Here, the r is varying from 0 to capital R. Therefore, electric field intensity. This is clear. Then the electric field intensity is given by at P due to disk. It is given by E is equals to sigma x by 2 epsilon naught integral 0 to r dr by r square plus x square whole power 3 by 2. And once you got this one, in that particular case, what you are going to get is here, put r square plus x square is equal to p square. Differentiate both sides. Then you are going to get 2r dr plus 0 is equal to 2p dp. Therefore, r dr is equals to p dp. Therefore, E can be written as sigma x by 2 epsilon naught integral 0 to r p dp by p power 3. Therefore, this is sigma x by 2 epsilon naught p power minus 2 dp 0 to r, or sigma x by 2 epsilon naught minus 1 by p, because minus 2 plus 1 by minus 2 plus 1 minus 1 by p. Then this is given by E is equal to sigma x by 2 epsilon naught into minus 1 by root of r square plus x square 0 to r. That is sigma x by 2 epsilon naught into minus 1 by root of capital R square plus x square minus 1 by root of 0 plus x square. Therefore, sigma x by 2 epsilon naught minus 1 by root of r square plus x square plus 1 by x, or sigma by 2 epsilon naught into minus x by root of r square plus x square plus 1. Therefore, E is equal to sigma by 2 epsilon naught into 1 minus x by root of r square plus x square, but this can also be written as sigma by 2 epsilon naught into 1 minus cos theta, since cos theta is equals to x by root of r square plus x square. This is how we are going to calculate the electric field intensity due to a charged disk. And then come to the other one. A thin uniform rod has a length L. A thin uniform rod has a length capital L. has uniform charge distribution along its length. If Q is the total charge on the rod, then find the electric field intensity. Then find the electric field intensity. On the axial line. Then find the electric field intensity on the axial line at a distance smaller from the nearer end. So this is another one. A thin uniform rod has length capital L, has uniform charge distribution along its length. If Q is the total charge on the rod, then find the electric field intensity on the axial line at a distance smaller from the nearer end of the rod. Then how to calculate this? Suppose this is a thin uniform rod. You are asked to calculate the field at a point P. Axial line means the line which passes through the length of the rod. Now this is given by R. Then if this is having a length L, this becomes R plus L. If you are going to find out this field at P due to this elemental length, then first we have to consider an elemental length in this. Suppose this is R you are given, an elemental length dl at a distance x from this. Then here this is the rod of length L, this is one end and this another end. You can take like this, thin uniform rod you can assume, and therefore what you are going to get is, what is the field at this point be due to this is, along this is. Then what you are going to get? First of all, if you can take charge on elemental length is given by dq is equals to elemental length into linear charge density. Elemental length is given by dl, linear charge density is given by charge q by length L. This is dq. Therefore, field at P due to elemental length. Therefore, electric field at P due to elemental length. If you are going to calculate, then d is equals to 1 by 4 pi epsilon naught into this is elemental length. Consider an elemental length dx. This is at a distance x on. So 1 by 4 pi epsilon naught into d cube by x square. So consider an elemental length dx at a distance x from the point P, then elemental length dx into charge this one. Therefore here d is equals to 1 by 4 pi epsilon naught into dq can be written as dx into q by L into 1 by x square. Therefore d is equals to 1 by 4 pi epsilon naught into q by L into x power minus 2 dx. Therefore electric field intensity due to rod, it is given by E is equals to 1 by 4 pi epsilon naught q by L integral r to r plus L x power minus 2 dx. Minus 2 plus 1 minus. Therefore 1 by 4 pi epsilon naught q by L into minus 1 by x from r to r plus L. Therefore 1 by 4 pi epsilon naught into q by L into minus 1 by r plus L plus 1 by r. Therefore E is given by 1 by 4 pi epsilon naught q by L into minus r, first one you can take 1 by r minus of 1 by r plus L. This is one form. Or otherwise, by solving this, simplifying that also, you can write E is equal to 1 by 4 pi epsilon naught into q by L into r plus L minus r by r into r plus L. These two gets cancelled, and therefore you are going to get E is equals to 1 by 4 pi epsilon naught q by L into L by r into r plus L. Therefore E is equals to q by 4 pi epsilon naught r into r plus L. This is another point. Another point. This is another one. Next one. Next one is a conducting sphere of radius capital R is carrying a charge Q. A conducting sphere of radius capital R is carrying a charge Q. Then find the electric field intensity at points R less than capital R is equal to capital R greater than capital R. You may be asked these 3 points here. Now, conducting sphere, this is a sphere having a radius capital R. For any conducting sphere, the charge always resides only on its surface. So, the charge always resides only on its surface. Is carrying a charge Q. For any inside point, so first one is at R less than capital R. That is for inside point. If you consider for inside point, suppose this is a point P and you are asked to calculate at this point, this is R you have taken. E for the inside point becomes 0 since no charge is present inside the conductor. Since no charge inside the conductor. No charge is present inside the conductor because for any conducting sphere all the charge resides only on its outer surface. B bit at small r is equal to capital R, that is for at the surface. If you are taken, then E at the surface is given by 1 by 4 pi epsilon naught into Q by capital R square. Because the entire charge is residing only on the outer surface. And third one, this is 2, and the next one is for any outside point, for any external point, C bit for R greater than capital R, that is for any external point. For any external point, then what happens? E at the external point for this is considered to be a point charge, then it is 1 by 4 pi epsilon naught into Q by small r square. Therefore, when a graph is plotted between the small r and this E, you can always find like this. This is for R is equal to capital R. This is for R is capital R, E inside point is 0. This is E and this is maximum. For R greater than capital R, E external point is proportional to 1 by R square. This is the for conducting sphere of radius capital R carrying a charge Q, and then another one, a non-conducting sphere has radius. A non-conducting sphere has radius capital R. A non-conducting sphere of radius capital R, a non-conducting sphere of radius capital R is carrying a charge Q. Find the electric field intensity at points A bit R less than capital R is equal to capital R greater than capital R. If you are asked like this, then first thing, for any non-conducting sphere, suppose this is the charge that resides throughout its volume, it's like this. For a conducting sphere only, the charge resides on its surface. Now this is carrying a charge q, this is having a radius r, and you are asked to calculate at point P at a distance r. Now once you are asked to calculate field at this point, this is the point P at a distance r from this. So what is the charge enclosed in that region? First we have to calculate. So A bit for r less than capital R, that is for inside point. If you consider, first of all, what is the charge enclosed is given by dq is equals to, what is the charge enclosed in this region? Volume into volume charge density, because it distributed over its volume, but volume is given by 4 by 3 pi small r cube. Volume charge density means total charge by total volume 4 by 3 pi r cube. Cancel, cancel. Therefore dq is equals to q into r cube by capital R cube. Therefore here field, therefore E for inside point is given by 1 by 4 pi epsilon naught into dq by small r square. Therefore it is 1 by 4 pi epsilon naught into q into r cube by capital R cube into 1 by r square. Therefore for E inside point it is given by 1 by 4 pi epsilon naught q by capital R cube into small r, which implies E proportional to, E inside point is proportional to R. At the center small r is equals to 0, therefore E at the center becomes 0. This is for inside point, and for remaining two it is same. The second one, B bit at small r is equal to capital R, that is at the surface. If you are going to calculate, E at the surface is simply given by 1 by 4 by epsilon naught into q by r cube into r. In the place smaller, if you write capital R, these two gets cancelled. Then E at the surface is given by 1 by 4 by epsilon naught q by capital R square. And C bit at r greater than capital R, that is for external point, you can take that one, that is E at the external point is 1 by 4 by epsilon naught into q by r square. Therefore, when a graph is plotted, so these are some models based on continuous charge distribution. Like that, we can also calculate for an infinitely long wire or a plain sheet. Like that also we can calculate. For all this, this is the general procedure that we have to follow whenever there is a continuous charge distribution. Okay? So, for more videos, please subscribe to my channel, and for any doubts, you can mail to the given mail ID forestrettysrinivas@gmail.com. Okay, thank you.